So regression is this very nice complement to correlation, which is simply explaining how one variable affects another variable. So another way to say that is that it's quantifying the relationship between how a dependent variable is affected by an independent variable. So you've got this independent thing, and then this other thing is like, hey, what are you doing? I'm going to come with you, or I'm going to go this way, right? So I mean, the idea of simply just thinking about what dependent and independent is, I think is important, because what it does is it helps to predict an outcome. And I want to feel really secure about the information that I'm sharing. So I want to know that what I'm saying really is a statistically significant relationship. So if I threw a paper airplane over at you and it landed right in front of you and I said, hey, I'd like you to do my social survey, would you do this? And you say yes, and you answered those questions, I can predict probably the types of answers that you're going to offer, knowing those relationships. And that's helpful, right? Because we don't have the chance, like Kevin talked about last time, we can't sample everyone. And so we have to have these ways that we can feel comfortable and confident with the information that we've gathered thus far to know that it really is predicting an outcome in the future. So I could throw 95 paper airplanes out there if it was below 0.05. If I took 100 and I subtracted 5, that gets to 95. And that's a good score. That's a solid A. So you're thinking about the fact that pretty much I'm going to see this relationship most of the time, I think is just important. So he's already mentioned, alpha less than 0.05. That's pretty typical in the biological sciences. Sometimes in social science research, you'll see that that number may even go up to 0.1, depending on what the questions are. So I have a couple tools that I thought we could utilize and do a couple statistical tests together. I wanted to grab both a social component and ecological component. So I grabbed a couple of lines from my own research that I haven't really done much with yet. One is an ecological piece on the number of plant benefits that people have shared through surveys. So that's simply asking not only about use for a plant, but of the important plants that you utilize in your life, which of those have particular benefits. And I just simply scored that by counting how many benefits were shared. The demographic information we'll utilize is about the percent lifetime that somebody's lived in a particular region that they are. Because I have a hunch that maybe the longer you live in a place, you might know the plants better and you might have more plant benefits. So that makes sense, right? Thinking about a positive relationship that could be possible from that information. So there's two links here, and then let's go to the inferential statistics to do, or the you can tell I've been teaching a lot, the worksheet that's in Google Sheets. So the free online calculator is another one of these sites that you have to figure is going to bomb you with ads, but nonetheless, it's danielsoper.com, who offers a lot of different statistical tests. And if any of you are familiar with Google Sheets having different add-ons, one of the add-ons that's actually very useful can be this Excel minor analysis toolpack. So if you haven't downloaded that, you can feel free to do that while we're talking, or maybe afterward, kind of sticking it into your Google Sheets, and it'll just be in there for you to utilize as you move forward. So I don't have the chat open. Is there any questions right now or items to discuss? Okay, cool, thank you. So I have the data open, and let's please go to the correlation and regression tab that's here. So if you have this copied already, that's great. Feel free to play along. So I have the two columns here of the lifetime for adults that lived in the region. And just FYI, average time is about 50% of their life. And the average age of the people that I spoke with was about 56 years old. So this is a mix of men and women. And there are 35 individuals that I spoke with. And then the plant benefits are listed in column C. So I like to first run descriptive statistics and freeze my panes. And I know that Kevin showed you guys how to do that already so that I can actually know what all this information is when I scroll down. And a couple things I just kind of pre-placed in here are, looking at those counts so that I'm clear on how many data points I have in each one of my columns, average, and then the min and the max, because I just want to look at it. I want to do common sense check. Does this make sense? If I had a max that was, 120% of their life, that would be a red flag for me. So these all look good. It looks like the average 51% of their lifetime, as we talked about, and then about 5 plant benefits. So I tend to first go ahead and just quickly just show these visually. So that's what each of these charts are here. And again, it gives me that idea that this is basically kind of normally distributed, right? That can be useful depending on what type of statistics I want to run. So I'm looking at this and I'm thinking, okay, lifetime in the region, looks pretty good. Plant benefits, same thing, looks pretty normal to me. And then over here, plant benefits versus the lifetime in the region. Obviously, I would make these a lot prettier if I was putting them into a paper, but right now I'm just quick and dirty. This is my worksheet, so I'm going to put it together in the way that I want to. And this is just simply showing, okay, so collection of dots looks pretty similar, has a trend line of some sort. So good. I think this is something that I want to look into and look further. And I like to just color code the stuff that I calculated so that I know it's different from my data set. So I can see that these are all my data points up above, and then down here below is where the information that I've gathered and I've done. So let's do Pearson's correlation, which is actually super simple and great when we can actually find something that already is in Google Sheets. So I'm just going to type equals to be able to bring up that function. And I'm going to type Pearson, and I'm going to put the two arrays of the columns of information that I want to compare. So that's simply going to be % lifetime for adults in the region by the number of plant benefits. Did I get them all? No, I didn't. Hold on, I'm starting over. Okay, and I'm also going to write Pearson's R, because I do not like later on thinking, what did I calculate in that box? Even though I can always look at the formula, right? So round 2, Pearson's, and I'm pulling down to B36, and I'm going to do the same thing in column C. Okay, great. So 2 to 36, 2 to 36 looks good. Great. Okay, so my Pearson's R that I calculated is 0.4. So that's right at that level. If you remember from the previous slides, that's right at that stronger level. So it's worth looking at. You know, that range can be different in different fields, but in general, I'm going to go ahead and kind of like go for looking at and seeing if this is something that has statistical significance or not. So 2 ways to do that. We remember down below that our N, right, is 35. So those are the 2 pieces of information that we need for using Daniel Soper's site. So those links are over here on the side, if you can see those. And then I'm going to go ahead and go to that link, which I think I already have open somewhere. This thing is breaking me. I tried to use your Stats Kingdom, but it's kind of weighing me down here right now with ads probably. Okay, so here's the p-value calculator. These are usually really quick and dirty. They don't explain at all what they're doing. It's just kind of like a magical box and the information pops back out, right? But sometimes this is all we actually really need. So I'm going to put in the correlation 0.40. The sample size was 35, and I'm just going to hit calculate. And so the p-value that pops out is, okay, down here. And so I'm going to take the two-tailed probability because I wasn't really sure. I had an idea, but I wasn't really sure exactly what direction all of this was going to go. And that's 0.017. So I'm going to go back to my worksheet if I can find it. Oops. Why does that happen? Okay, coming. There we go. And I'm going to put in here my p-value, which is just the output of my regression, and that was 0.0, what was it? 1? 8. There you go. 0.017. Okay, great. Double checking is good. Okay, great. So I have that information now. So that is below 0.05. That says to me that there is a statistically significant relationship. So as you spend more time, percentage of time over your adult life in the region, we're seeing people responding with more number of plant benefits. So that's cool. There's another way to be able to do that, and that is through this Excel Miner add-on. So to add an add-on in Google Sheets, you're simply going up to add-ons, and you're going to go to get add-ons. I already have it here. That's why you already see it listed, and I can just start that program. So from here on out, if you download that right now, you're going to be able to have it and get add-ons. And I found this one simply by putting in regression because I really wish there was a tool within Google Sheets, and there isn't. And what? Can't find anything. That's so mean. Too many S's. Okay. Here we go. And it's the Excel Miner Toolkit is actually the only one that Miami approves, kind of whitelisted for you to download. So there you go, that'll answer that. And then you'll just download that one and it'll show you it's installed when you try to search it again to see. And then the add-ons are here. So I'm just going to open this Excel Miner tool pack. How do I get rid of you guys? Can you see this, or is everybody over top of this here? Is it just me who can't see it?
We can see it.
Okay, cool. Thank you, Kevin. So this is all of the different statistical tests that can be run in the Miner tool pack. There's a lot in here. And again, I don't understand all of these things necessarily. I haven't used them all, but I've heard of a lot of the terms. And if I needed to use it, I would know that it was here in this tool pack. So I'm going to scroll down to linear regression, and I'm simply going to enter the two different data sets that are in here. And it's just another way to get at that information. So maybe in the interest of time, I won't go through that full. Is that okay? Were you okay for time?
Yeah, that's fine, Jill.
Okay. So basically we just go in and we want to input the different information here. So I'm going to put in what I'm wondering about, the dependent variable, and I'm wondering if it's the one that will change versus the other is the plant benefits. So I'm going to actually highlight this column, and I'm going to grab the label just so that it helps me remember what information I was inputting. I'm going to put that here in for range. So this is an interesting way that it works. You actually have to highlight the information, then you click in the box. Because if I click right now in this next box to put in the X range, it's going to put the same stuff in because that's what I already have highlighted. So it can be a little bit frustrating. This is why I was saying it's a little bit clunky. You'll get a chance to see me clunk around in it. So I'm going to move over to the next column here, and I'm going to grab this info, and I'm going to dump that in also. And I'm just going to click here for X input. Great. So I have C1 to C36. That makes sense. And B1 to B36. I'm going to put in that I want the labels to be showing because it just helps me to look at the output of the information that's being offered. And I want the output range to land in a certain spot on my spreadsheet, right? Because I probably have a bunch of other things going on. So I'm going to say that I want that summary output to land here in whatever cell that is. So I'm going to poke it here. So then you can see my cursor is on G3. And then as soon as I click over here in this box, that's how it ended up auto-populating that. And I'm just going to say, okay, I'm going to be hopeful. Okay, yay. So I got a big bunch of summary output information. And right now, I'm not going to worry about all of this because, well, one, it's 8:05, and two, we're only looking for the p-value. So I try to not get overwhelmed by looking at some of this information, right, and thinking about it. But I can see here that the p-value is 0.016. And I'm going to go ahead and color code that so that I can see that that is one of the information pieces that I have calculated kind of throughout the information that I have here. So good, those are basically the same. From those two outputs. And I think that that helps to kind of think about how you can run this type of information. So you may have some data sets that you want to try to look at and see if they have that statistically significant linear relationship that you can find through correlation and regression. Hopefully that helps you. And there's also a correlation regression solved tab that has all this information in as well, so that that might be useful to you kind of afterward from here.